Today we're looking at the nucleophilic addition mechanism, reactions between nucleophiles and carbonyl compounds. Today we're going to exemplify with an aldehyde, and this aldehyde is ethanol because it's got 2 carbons long. Remember, it's an aldehyde because there's a hydrogen attached to the carbon rather than another carbon here. The nucleophile is a cyanide ion, and what you might find strange is that the lone pair of electrons in this nucleophile is actually attached to the carbon, not to the nitrogen. We do tend to draw the negative charge after the letters, but realistically, what we should also usually do is put the negative charge on the carbon, but you won't get marked down for that in an exam. Okay, so it's a nucleophilic addition. Why is it nucleophilic addition? Cyanide is a nucleophile, it is electron pair donor. So a curly arrow from the lone pair of electrons on the carbon of the cyanide goes to attack the carbon of the carbonyl bond. It is electron deficient because of the electronegativity of the oxygen here being much more than that of the carbon. As we have got attack with the lone pair of electrons to the carbon, which is going to form a new covalent bond, the carbon atom must break its carbon-oxygen double bond, and it does it like this. Okay, so then we are left with this species here. Should just bring it to view, which is this species with the cyanide attached now, making the covalent bond, and we've got a single bond between the oxygen and the carbon. Because that electron pair from this bond ended up on the oxygen, it has got a negative charge, and we show the lone pair of electrons. And these lone pair of electrons attack a hydrogen ion or a proton, which will be added into the solution at the end of the reaction. If we scroll along a bit further, we will see, oops, just let me move this, let me just move my molecule slightly, and then what we see is this, that we are left with this molecule which has got this CN group, which we now call a nitrile, and it's got an OH, which is obviously an alcohol. This molecule is called a hydroxynitrile, and in fact it would be called 2-hydroxy propane nitrile. Okay, so that's just the mechanism. What you can see here in this mechanism, particularly when we react with aldehydes and and cyanides, is we now get this carbon atom has 1, 2, 3, 4 different groups attached to it. This means it is a stereo center. It's a chiral molecule, and in the next video we're going to investigate how we can explain the stereochemistry of these products.